LPP stands for linear programming problem. This is a very crucial mathematical tool used in various fields like economics, manufacturing industry, and so on, in order to finding out maximum profit and optimizing the resources in the industry. It is most often used in the fields. There are various algorithms and methods to find out the maximum profit, but we will use simplex method here. So let's start how we solve the problem using this simplex method. First of all, we have to convert inequality subject to constant equation into the equality. As per the type of constant, we have to sometimes add slack variable, sometimes subtract the surplus variable, and sometimes add artificial or dummy variable. In the first case here, only slack variable is added. In the second case, greater or equal to case, we have to subtract surplus as well as add artificial variable or dummy variable. In the third one, we have to add artificial variable. For furthermore understanding, let's go through a problem. Here is a problem. Solve the following linear programming problem LPP using simplex method. This one is objective function and this one is subject to constant inequality equation. We have to change it into the equality function. Since the constant is um, first type of constant, so we just need to add slack variable in order to changing into the equality. We have added S1 slack variable, S2 slack variable for next inequality equation. After all, we have to put this coefficient of the equation into the simplex table. In the first simplex table, basically simplex table structure is like this: row, basic, Cj, x, y, and slack variable we have added, constant, ratio, and operation. This row has first inequality equations coefficient, and this row has second inequality equations coefficient, and this row has maximum z or objective functions coefficient. Basic as slack variable s1 and s2, and this row has coefficient of slack variable r1 equal to 0, r2 equal to 0. Coefficient of s2 is 0. Your main thing is to calculate ratio. For calculating the ratio, we have formula constant upon key column element. In the first step, we have to find out key column element. Key column element can be determined by finding out less number in the indicator row. This is the indicator row. Indicator row has your -4 is less number. -4 is less than minus 3, even less than 0 as well. So this column is the key column. Then we can calculate ratio. 10 is the constant and 2 is the key column element for this row. 6 is the constant from here and divided by key column element for this row is 6. Then we have to determine pivot element. How could we determine pivot element? Is the row which has least ratio. 5 is less than 6, so this row is key row element, and the key column element. The intersection of key column and key row element will, will help to finding out pivot element. So in this case, intersection of this row and intersection of this column have to find out pivot element. Here 2 is pivot element. Then what we have to understand from here is, in the next operation, in the next table, we have to apply the operation. Why we need to apply the operation? We need to change pivot element into 1 for the pivot element row. Element under the pivot element, we have to make 0. So in this case, we have two operations for this row and for this row. Unless indicator, unless all the element in the indicator row is positive, we will never get the optimal solution. So we'll do same process repeatedly unless we get all the element in the indicator row positive. Here -4 and -3 is negative, so we'll have to do for the next process and next operation. As I have already told that we have to apply the operation in this row. We have to make pivot element 1. This operation will have to make 1, and for other element as well, same operation will apply. Our input will be table 1 row 1, which should divide by 2, and our next operation for making element under the pivot element 0 will have through this operation. Row 1 value of table 2. Row 1 value of table 2 means this value. We'll subtract from the row 2 value of table 1, means row 2 value of table 1 means this element, this element, this element. All the element in this row will apply same operation. After these two operations apply in row first and row second, we will have to calculate ZJ and ZJ. ZJ is always calculated from R1 into this column variable plus R2 into this column variable. In this case, we have 4. For the next case, we'll multiply R1 into this element plus R2 into this element. Then our result will be 2 in this case. Similarly, we'll find out here and we'll find out here. Zj minus Cj, we have Zj and we have Cj here. Will minus 4 minus 4 0, 2 minus 3 minus 1, 2 minus 0 2, 0 minus 0 0. Likewise, we have pivot element 1 by 2. Since 2 is less than 10, this row is this row is key row, and minus 1 is least element among this row element, and intersections of this column and this row is 1 by 2. So our pivot element is 1 by 2. Later on, this y will jump into in the place of S2, and the coefficient of y3 will jump in place of R2 equal to 0. In next case, R2 equal to 0 will be changed into R2 equal to 3. Since we have pivot element in this column, in y column, then it will jump into the R2. In this step, we will get Zj minus Cj indicator row. All the element in the indicator row is positive. Since then we will get the optimal solution. We have x decision variable equal to 4, y decision variable equal to 2, and maximum profit z equal to maximum profit z equal to 22. We can check it putting the value of x and y we have get into the objective function like this. If value is same as we obtained from simplex table, then our result will be correct. Thanks for watching. Thank you all.